Hey guys, welcome back to the channel. I have a short video for you guys today, but in this video we'll be covering the different types of linear equations and functions, which will be preparing you guys for the next video, writing equations for lines. Um, so before we hop into the meat of the video, don't forget to follow the channel's Instagram page, the Swiss Army Tutor. It'll be in the description down below, and also leave a like on the video, subscribe to the channel, and hit that notification bell for more information. So let's just hop right into it. So in a previous video, we defined a linear function and a linear equation as a degree 1 polynomial, meaning its leading coefficient, its leading term is raised to the power of 1. So and x to the 1 is equal to x. So a good example of this is f of x is equal to 3x plus 2. Okay, and also in a previous video, we defined the equation of a line as y is equal to x, which is the parent function of a linear function, as a line going straight to the origin, with a slope m, with a slope 1, and essentially. In the last video, I also forgot to mention slope, that m being 0, if m is equal to 0, it's a horizontal line, meaning it's a constant change. And if we have a vertical line, if m is vertical or undefined slope, then it's vertical. So it's important for us to classify the different types of equations before we start writing the type of equations. So we have standard form. The first form we have is standard form. It's the most basic form. You guys have seen it everywhere. So similar to a quadratic, which we'll be covering later on in the next chapter, it's ax plus by is equal to c, or ax plus by is equal to c. Either of these cases, they're in standard form. And essentially, we derive every other piece of equations for a line from this. All right. So pretty much this is the case for polynomial form. But if we were to graph the function, we could solve in terms of x or y. So by subtracting, an example of this before we actually move on. So an example of this would be 3x plus y, 2y is equal to 7. A good example of that. All right, and then from that, so let me zoom out a little bit so you guys can see everything. There we go. Got a new marker for you guys. So from here, if we have ax, let's rewrite this in orange, our new piece of paper. If we have ax plus by, or that bigger. If we have ax plus by is equal plus c is equal to 0, where c is a constant. So c is a constant. So if we add or subtract it, it's not really going to matter that much in this case. But pretty much, so pretty much if we subtract c from both sides, it leaves us with ax plus by is equal to c. Like I said, c is a constant. It's a constant. So if we add and subtract it, in this case, for simplicity's sake, we're just going to leave it as positive. We're just going to say it's positive, but technically it would be negative c if we were dealing with numbers, actual real numbers. And if we subtract ax, so the constant term pretty much affects, so that affects the y-intercept. But in this case, we're just putting them in different forms. We have. So that leaves. So if we subtract ax from both sides, we have by is equal to c minus ax. All right. And then if we divide by b to isolate y, we have y is equal to c over b minus ax. Okay? All right, this is similar to the form of y is equal to mx plus b. So those are the steps we take to write the slope-intercept form. Slope-intercept form, the form that we write equations of a line. This is important to know. Y is equal to mx plus b. Okay, where if m is greater than 0, it's sloping, positive slope. M is less than 0, negative slope. M equal to 0, no slope. Okay, another thing. All right, so we use this form to graph. So this is used to graph. We use the slope-intercept form to graph lines. So we have one more form, which we'll go in more depth tomorrow, which requires a point, and we have point-slope form. If you guys remember the formula for a slope, so m is equal to a change in y over a change in x, delta y over delta x. So pretty much this could be rewritten as, so if we multiply by 1 over delta x, so m times 1 over delta x is equal to delta y, sorry about that, times 1 over delta x over delta x. Oh, sorry, multiply by delta x, not 1 over. Well, that cancels. That becomes 1. So we have, that leaves us with m times delta x is equal to delta y. And delta x is, so m is equal to x2 minus x1, which is equal to, and y is equal to y2 minus y1. You guys remember that? So let's rewrite that on another sheet of paper. So, so m times x2 minus x1 is equal to y2 minus y1. Okay, now this could also be written as x naught versus x naught minus x final minus x initial. So this where this is initial, x naughts, and this is final, xf or x. All right. So for simplicity's sakes, we could define this so x2 as x and x1 as xo, x of 0, which is also the initial, or x naught, which is also known as, and this is, so move my hand out of the way. This is y2, y, which is y. We're going to leave it as y, and y1 is y, yo, which is the same as y naughts, or which is the same as saying, oh, it's the initial spot. So that's how we define change. So if we rewrite it, we have m times x minus x naughts, x1 or x naughts is equal to y minus y naught. Okay, and so from here we solve for y. We solve for y and simplify down to and simplify this side down to get into standard form. And then we simplify down the standard form to get into point slope intercept form to graph. And I'll talk about what this means in the next video. But just a quick recap. Pretty much, there's three types of linear functions, or three different forms, not types. Standard form, which is ax plus by is equal to c. It's the most common form for things being jumbled. We have the slope-intercept form, which is saying, which is y is equal to mx plus b, which is what I showed you guys in the previous video. And it's what we use to graph lines. And in the next video, we'll be talking about point-slope form and writing equations for lines. Pretty much, it's y minus y naught is equal to m, the slope, times x minus x naught, which you guys see here. Sorry about that, guys. What you guys see here. All right, and also we are required to have a point and a slope to write out an equation. So with that being said, guys, I'll see you guys next video, and keep on rocking.